Hello. Today we're going to learn about building the schedule. What do we mean by building the schedule and how to break down a big project into smaller components, along which lines, and how many activities should a project have, and so on and so forth. So basically what we're going to discuss is how to identify the activities in a project, how to determine the activity durations and the relationships among the activities and linking them and so on. This is going to be a review of what we learned before about the different types of relationships and so on, but we're going to talk primarily about the first task in schedule development, which is activity definition, how to break down the project into activities. So construction planning can be either cost-oriented or schedule-oriented, and to give an example on that, the cost-oriented is going to look at the direct costs and the indirect costs. The direct costs are basically costs involved directly in the construction operation on site, whereas indirect costs are going to be costs needed to be spent on the project but not necessarily related to any particular activity. So for example, if you have a central purchasing department at the headquarters of the company, this purchasing department is working on all projects, or any scheduling department, or any central department, the legal department, for example. You cannot pinpoint and say they worked that long on this particular project or that project, so it's going to be a general overhead for the head office, whereas direct costs are going to be the cost of the people assigned to the construction site, field engineers, superintendent, project manager, etc. When we look at the time aspect of the project, the schedule-oriented idea, we have time-oriented, which is going to be developing the critical path of the project, and resource-oriented, which is going to be what kind of resources do we need, when are we going to need them, in what amount, and so on and so forth. This resource-oriented planning is going to be sort of joint between the schedule-oriented planning and the cost-oriented planning, because again, every resource has its own cost, so we need to calculate the cost of these resources as well. Before starting our scheduling effort, we have to read the specifications and the plans, because, for example, the general conditions of the contract are going to have an effect on the selection of the activity and the sequencing of the activities and the responsibilities and so on and so forth. The staffing of the project, of course, is going to be also contingent upon these plans and specs. Choosing the appropriate technology. What kind of technology is going to be available in the project location and affordable to the company that's going to be undertaking that project. Identifying and listing activities. How are we going to break down a huge elephant like the project into more manageable tasks or activities the size of an ant compared to that elephant? And then calculating the activity durations based on the resources that are going to be identified for each activity and the resource availability, whether it's money or materials, equipment, subcontractors, etc., and labor. Identifying the relationships between activities. So which activity comes first? What's going to be the predecessor to what? What's going to be a successor to what? Which two activities can be done at the same time? And what kinds of lags and overlaps, what kinds of constraints are going to govern the relationship between activities? All of that has to be involved. And then once we identify the relationships, after breaking down the project into activities, we have to link these activities. And once we have linked them, now we're going to add the durations that we have already calculated to calculate the activity times and the project duration based on the algorithm of the critical path that we have already learned about: early start, early finish, late start, late finish, total and free float, which are going to be calculated from the forward pass, the backward pass, and determining the critical path of the project. When we talk about the choice of technology, it's the choices of appropriate technology and methods for construction, which sometimes are often ill-structured, yet critical ingredients in the success of the project. So if we do not have a clear structuring of when are we going to need this piece of equipment, we might end up acquiring it too early, which is going to result in additional cost, or too late, which might result in a delay to the project. Same thing applies to the materials. If there's a shortage of that material, we have to order it in advance. It might be a long lead item that needs a long time to manufacture or to get ready for delivery to the construction site. So we have to plan for the cost of storage and storage conditions and so on and so forth. Or are we going to rely on just-in-time delivery to the construction site at the time when the activity is going to be performed, therefore not needing any storage? Of course, the danger with just-in-time planning is that if you need it right now and it's not delivered right now, that means that you're going to have a delay. We need to consider the constraints of the site and the influence of selected technology on schedule and cost. So again, constraints of the site could be either logistical constraints like access to the site, for example. It could be political constraints. It could be other constraints that might affect the site. So weather constraints, for example, maybe there are some activities that have to be done in a dry environment. So if it rains, we cannot perform them. The tower crane should not be working when the wind speed exceeds a certain speed and things like that. So we're going to look at the meteorological reports from previous years to try to identify what are the constraints that are going to be imposed on our construction activities. To identify in the list activities represent the necessary framework to permit scheduling, along with estimating the resources required by the individual activities. So again, that's why we need to have clear distinction. What is this activity? What amount of work is going to be associated with that activity? What kind of resources are going to be needed? In what amount? And what's the cost of these resources? What's the production rate of these resources? All of these details are going to be required for each activity. That's why we might end up having something like an activity form that shows the name of the activity, its location, who's responsible for it, what kind of resources are going to be involved, what are the rates of application or rates of performance of these resources, and that leads at the end to the duration of the activity and the cost of the activity. The set of activities defined for a project should be comprehensive, but not too refined, because again, there's a very high likelihood that we might end up adding activities or consolidating some other activities. So basically, we're going to think creatively based on our experience. How did we do it in the past? And we're going to develop a set of activities, but again, have an open mind for the possibility of adding additional activities. If, for example, the activity duration exceeds, let's say, a couple of weeks, maybe we need to break it down into two. Or if the duration of the activity is less than 1 day, maybe we need to consolidate it with another activity to be more meaningful. Construction plans can easily range between less than 100 activities to several thousand defined tasks. And again, we are usually going to start with a very summarized schedule or collapsed schedule that's going to have the main milestones. When do I need to start work? The notice to proceed. When do I need to finish the underground work? When do I need to finish the skeleton, the topping off of a steel structure or the completion of a concrete structure, for example? When do I need to have enclosed the building to start the dry work inside the building, and so on and so forth? When is going to be my substantial completion? When is going to be my final completion? So we are identifying major milestones in the project, and that's going to be my main initial schedule, and then I'm going to fill in the blanks. So this is like a skeleton, and then I'm going to add the flesh and the skin and all the other details to that schedule. Typically, each design element in the planned facility will have one or more associated project activities. So the foundations are going to have probably more than one activity. The walls are going to have more than one activity. The HVAC system is going to have more than one activity, and so on and so forth. Those activities will involve different resources, or those activities that do not require continuous the two major types here: activities that involve different resources, like any production activity, for example, or any procurement activity, and those activities that do not require any continuous performance, like submittals. One of the activities is to submit a sample to the architect engineer for review and approval, or reviews. We're going to have a review of a certain document, or we're going to have an inspection, or something like that. Building element classification can be used as a guidance to list, group, major building activities. So we're going to have foundations, superstructure, mechanical system, electrical system, etc. These could be major classifications under which I'm going to break them down into smaller entities until I reach the level of activities. So here, for example, is one of the formats. It's called the Uniformat, and it's sometimes used in estimating and in bidding as well as in scheduling. So here, for example, we have the structure, the substructure, the shell, interiors, services, etc. And each one of them shows a little bit more level of detail. So the substructure is going to have foundations and basement construction. It could also include any infrastructure utilities, pipes, cables, etc. And then we can break it down even further into standard foundations, special foundations, slab on grade, basement excavation, basement walls, and so on. Each one of these can be further broken down. So standard foundations, we're going to have basically maybe formwork, rebar, concrete, and then backfilling and beams connecting these different foundations, or pile caps for piles and things like that. All of these are going to be different details for each one of these activities. Another method which most of you are probably more familiar with is the Masterformat. The Masterformat used to be known as 16 divisions in the past. That is what most contractors are familiar with. And then the Construction Specifications Institute, or the CSI, which is the body that developed both the Uniformat and the Masterformat, came up with a newer format in 2004. Instead of the 16 divisions, now it's anywhere between 48 and 49 divisions. So they broke down these divisions into more details, and there are some divisions that are still blank, reserved for further addition, like 36, 37, 38, 39. There's nothing in there, but something can be added in the future to this set of specifications. Our vehicle to convert the big project into the major tasks until we reach the level of details is called the work breakdown structure, or WBS. This is a very important tool to dissect the project until we reach the level of work packages, which can be broken down later on into activities. So a project work breakdown structure is a deliverable or product-oriented grouping of project work elements shown in graphical display to organize and subdivide the total work scope of the project. So basically what we're saying here is that the work breakdown structure is a graphical translation of the scope of work of the project. It can be used as a planning tool and as a control tool as well, to make sure that we did not skip anything or forget anything in our planning for the project. It is not an activity listing. It stops one step short, or maybe two steps short, of activity listing. So we stop at what's called a work package, which later on can be broken down into activities, and it usually follows what's called the 15555 model, which means each entity is going to be broken down into 5 sub-entities, and each one of these 5 in turn is going to be broken down in 5, and which one of these is going to be broken down in 5, until we reach a comfortable level of detail. Again, it's not yet the activity level of detail, one step higher, which we call the work package. So the decomposition of the total project work identifies the deliverables and the related work, and it follows a structure and organization, which is the WBS, decomposes the upper WBS levels into lower level detailed components, 1 becomes 5, developing and assigning identification codes to the WBS components, because we're going to use these for scheduling later on, or with some modification we can use them as cost accounts for our cost accounting for the project. In this case, instead of being called WBS, it's going to be called CBS, or the cost breakdown structure. Similar to that as well, if you can imagine something like an organization chart that shows at the top the president or the CEO and the vice presidents, and then the directors, and going down until you reach the field personnel. This is called an organizational breakdown structure, or OBS. So these three, the WBS, the CBS, and the OBS, break down one big idea into smaller levels that are even more manageable and controllable. Verifying that the degree of decomposition is necessary and sufficient. So again, this is a tool for review and for control to make sure that everything in the scope of work has been adequately covered in that work breakdown structure. The work breakdown structure includes 100% of the work defined by the project scope and captures all deliverables. It focuses on deliverables, not activities, as we just mentioned. That's why it stops at a work package. Activities can be created based on these work packages or based on these deliverables. To show you the flow of that work breakdown structure, we started with level 1, a house. That's the project that I want to build. I broke down that house into a following layer. Again, we call it 15555, but that's not carved in stone. It could be 1, 4, 7, 3, 6, and so on. But it's not going to be 1, 20, 100. So it's going to be a gradual transition from one level to another layer to a third layer, etc. So we have here the site preparation, footings and foundations, land, design, etc. Framing. The footings and foundations is going to include framing, roofing, utilities, etc. So again, you can break down each one of these levels into further details until we reach a work package level. Now we can see here, for example, coding system, Acme Motors expansion. The name is AM, Acme Motors. And then the automated system is AM01, conveyor system AM02, office building AM03, and then you can break that down, design and engineering of the office building, so it's going to be AM031, AM034, and so on. Each one of these can be broken down, so it's going to be AM03401, and so on. That's another example of how a work breakdown structure is going to look like. And we're going to finish here at the end at the work tasks, which can be broken down into activities that usually do not show on the work breakdown structure. Now from these work packages, we're going to break them down into activities. And each activity is going to be represented by a verb and a noun. Install carpet, paint wall, place or pour concrete, and so on. So there are three typical types of activities. Either a procurement activity, which is purchasing or contracting to get steel or to get mechanical equipment or to get elevators or electrical supplies or concrete. Production, which is the heart of the construction schedule, placing that concrete. And management, so the required submittals, owner or engineer approval, testing, and delays, which are not production or procurement activities, but they still form major milestones and flags and constraints in the project. Therefore, we need to reflect them on the schedule. We also have something called milestones, which we mentioned initially. The project start is a major milestone. The project completion is a major milestone. The building enclosed is a milestone. Substantial completion is a milestone, and so on. These are zero duration activities. It just shows that this is the separation between the previous phase and the following phase. Flags, we have something called the flag, which is half of a milestone. Start flag or finish flag. So if you look at the milestone, it can be split to two halves. There's going to be start, task, start, flag. Like, for example, the notice to proceed. Notice to proceed is going to act as a milestone or as a start flag for the rest of the project. And completion of submittals. This is going to be a finish flag. There could be a start flag for the submittals and a completion flag for the submittals, and so on. Activities should include action-related verbs. As we just said, verbs and nouns. Procurement is going to include verbs like fabricate, order, deliver. Production is going to include install, place, erect, paint, clean, demolish. Management is going to be submit, approve, review, apply for a payment or for a request for inspection or things like that. In addition to descriptions, activities usually have activity identifications or IDs, as we're going to see in the automated or the computerized schedule. We're going to have an activity ID and an activity description separate from that ID. The IDs can show locations, trades, and work types, etc., etc. If we go back a couple of slides here, this is an activity ID, AM03. It could, something like that. Basically, this is not an activity, but it can start. It can be the beginning of an activity. So if we go 3 levels below that, it's going to be AM03, 01, 12, 25, for example. That could be an activity. And here's an example. The first 4 digits are going to be a serial number for a project. And for example, here this is going to be a Masterformat CSI code, heavyweight structural concrete, and then 21 is the placement, and then it could be location, responsibility, and then column number 34 at the end. So each one of these numbers represents something meaningful, and we're going to have sort of a dictionary for these activity IDs so that anyone who doesn't really know can follow the explanation and the description in that dictionary to understand what this activity stands for. Here's another example. So now that we have broken down the project into activities and identified each activity, we need to start thinking about the activity duration. The activity duration, one more time, is going to be obtained from our famous equation, Q over P. So in practice, work task duration are determined by one or more of the following methods. Past experience, either we have done this activity so many times in the past so we can expect how long is it going to take. Estimates, based on Q over P. Order, you have to finish this activity in 5 days or something like that. Or use of predictive models. If we do this activity this way, it's going to take that many days. If we do it that way, it's going to take that many days. Again, it's based on both past experience and estimates. And the activity duration can either be deterministic or probabilistic. Deterministic, which means there's only one duration for the activity obtained again from the equation Q over P. But probabilistic is there is some probability that we're not going to finish in that duration based on the conditions, based on the performance of the resources, based on the availability of resources. So if we're looking at historical data, we may say we've done this activity 100 times in the past. 20% of the time it took extremely long. It took 10 days. 20% of the time it was really done in a short time. It took only 4 days. But most of the time, in 80% or in 60% of the previous 100 times that we've done this activity, it took 7 days. So now we have 3 different durations for the activity. 4, which is the shortest, 10, which is the longest, and 6 or 7, which is the most repetitive from past experience. Which one are we going to use to schedule the project? Now remember, this applies to every activity. If you have just 200 activities in the schedule and you keep adding these different probabilities, you're going to end up with the lowest estimate, which is 2 months, and the longest estimate, which is 18 months. You definitely cannot go to the owner and say, Mr. or Mrs. Owner, we're going to finish your project in 2 months or maybe in 18. That definitely is not going to work. Therefore, we need to factor all of these probabilities to come up with something meaningful with a certain level of certainty. And this is basically what we're going to discuss in a future lecture called probabilistic scheduling, and we're going to learn about a technique that we can apply to get one duration out of these 3 different durations for each activity. With the deterministic task duration, the activity may have a fixed duration, or a resource entity is to be captured for a specific time. So I'm going to have this excavator available for only 3 days. Therefore, I need to use it for a certain number of hours each day to finish that task. I have a fixed amount of work, and I know the production per hour. So how many hours per day, how many days, that's how I'm going to estimate the deterministic duration. The activity duration may be subject to small variations about a specific mean value, so that from any useful time scale, the work task duration is constant. The duration again is equal to quantity divided by production rate, Q over P, that we have discussed so many times so far. Now, when we talk about probabilistic duration distributions, we're going to talk about this in more details, but you're going to find that we have something called the mean, or the most likely duration, and we're going to have something called the optimistic duration, which is the shortest possible, and the pessimistic duration, which is the longest possible. We're going to see an equation based on statistics. How can we factor all of these three into one duration for the activity? Basically converting probabilistic into as much deterministic as possible. We're going to use something called production table or productivity tables. You can find some of these in the means book, for example, or in the Walker book for estimating. And definitely I would always suggest that each company builds its own production tables or productivity tables based on its own resources, whether it's subcontractors or equipment or labor or materials, etc. So the productivity table is going to show you, for example, that if the masonry unit size is 8-inch blocks with no conditions, then you can produce up to 400 units per day per mason. So knowing what's the total number of units that we need to place, we can divide it by the number of masons and get the number of days that's going to be needed, and so on. So you can see different conditions, and if the wall is long, then definitely we're going to have more production because you're going to have minimum interruptions, so we can achieve 430 units per day per mason. If the wall is not long, if it's a short wall with corners and a lot of interruptions and so on, that's going to reduce our production rate to 370 units per day per mason. So based on these productivity tables, we can estimate the duration of the activity. This is a quick review of the durations between activities, the relationships between activities we discussed before the finish to start, which is the most common relationship, also known as traditional relationship. And we may add here between the two activities a positive number that's going to be a lag, or a negative number that's going to be an overlap. We also have the start-to-start relationship, and again here we can add a lag between the two activities. It can be with or without lag. The finish-to-finish, same thing, connects the finishes or the ends of the activity. It can either have lag or without lag. And the fourth one, which is the start-to-finish, as we discussed before, very rare in its use, and usually it might have either lags or no lags. That it can go either way. Between the activities, again, we talked about lags and overlaps, so the lag is going to be a positive number, whereas the overlap is going to be a negative number. So basically, this is a quick introduction about how to build a schedule. So we're going to see some exercises that we're going to be working on. Taking a project, how are we going to break it down into activities or work packages, and then develop an activity list based on that to start our activity list, and then add the sequencing of the activities, add the durations of the activities, and then calculate our schedule based on the algorithms of the critical path method. I will see you in the next lecture.